Well, hello everyone. I can tell that Docker is quite a popular topic. Lots of people here. Before we start, because I'm not sure where I'm going to find, I want to ask a few questions just to see the kind of audience we have. I assume that you all have heard about Docker, but how many of you have played around with it? Okay, so most of you, good. How many of you are actually using it with Delphi? Okay, that's what we're going to change. It's much easier than you really think. Are you using Docker for any other projects at all? Yeah? Okay, so you're familiar and you're building your own images as well, or you're just using it to deploy a pre-built software somewhere? But okay, what we're going to do today, we're going to create an application using Delphi and deploy it in Dockerfile, hopefully. But yeah, first I want to do a brief intro. Well, who am I? In case any of you don't know me, my name is Zapater, and I'm a pre-sales consultant in Embarcadero. I joined Embarcadero almost 3 years ago, but I've been working with Delphi for many years, 15 to be more precise. I've been working with Linux microservices developed with Delphi, but I've also been a full stack developer. I've worked with Laravel, with Kubernetes, with Bootstrap, with Vue, also did React, but I hated every single minute of my life, so I don't even add it to my resume. And also I'm a big fan of Docker. Every time I have the chance, I do like to deploy in Docker, and we will see the reasons in this presentation. So this is briefly the agenda. We're going to do a basic introduction to Docker in case you don't know how the technology underneath works with Docker, and then why Docker matters, and well, you can read that, containers basics, Delphi advantages, blah, 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 blah. And of course, we will do demo. Okay, so what is Docker? It's a platform for developing, shipping, and running applications in isolated environments called containers. It was launched in 2013, and now it's pretty much the industry standard when it comes to deploying backend services and web services as well. They are very exotic services as well. I've seen customers deploy VCL applications in Docker, which you probably think, how? That was my question as well. So you can use, I'm just giving you some guidance here. Delphi binaries, VCL specifically, so they're Windows only. They get along very well with a technology called Wine for Linux. So you can kind of run a Delphi application with some caveats here and there in Windows. So if you use a Docker image that exposes a desktop through VNC, you can run a VCL application inside a Docker container. And I've seen it running. Of course, there are a bunch of things that can go wrong, like printer redirections, devices that you connect physically to the device, but it works. Not in every single scenario, but it's a technology that I've seen working. Okay, so yeah, probably if you're familiar with Docker, you know all these words. It's very consistent, it's very isolated, very efficient, easily to scale. Also gets along very well with DevOps. If we have the time, I will give you some guidance as well about DevOps and this whole CI/CD stuff that is very trendy now, and apparently if you don't use it from 20 years ago. And it's much easier than you really think to use it with Delphi as well. I will give, hopefully, we have the time, some guidance. And if you ask me, it's perfect. Delphi for microservices, for creating very small binaries that get into a very small image. I guess you all know this. I created this slide just in case you didn't know the difference between a VM and a container, because a lot of people confuse them and or they see them as the same thing, and they are very different. Primarily, the main difference. Let's jump to the other slide. The main difference is we have the infrastructure, the bottom layer, which is your server or servers or your farm of servers or whatever. Then we have the host OS, both cases, we're the same thing. But then for VMs, we need a hypervisor. It could be VMware, it could be Proxmox, it could be Hyper-V, whatever you choose the flavor. And then over that Hyper-V, then we start creating that hypervisor will start creating VMs. But they're like their own little thing with their own resources, their own core, their own RAM, their own operating system as well. With Docker, what we do, we install Docker engine that sits on top of Linux. So it's not a fully abstracted hypervisor, so it connects directly to the Linux kernel. So it's a layer that communicates directly with a host OS. There's this thing called Docker for Windows, and you can deploy Windows containers. Don't ask me, I've never used those. But, well, technically it exists, but 99.9% of the industry uses Linux for Docker. And then you have the containers. We can see on the right that the container only contains the app itself and the potential dependencies of that app. Full stop. With the virtual machine, you need to install a whole operating system. You can choose Debian, you can use Red Hat, you can use Windows, whatever. But that adds a lot of storage resources, etc. With Docker, much leaner approach. Okay, a few words in case you're not all familiar with these. We have Docker image, which is the final package. It's just we put everything already ready to go, and we put it in a place, and in one file we can pull from multiple places, and that's called Docker image. Once we convert that image in a running application, that's when we have a container running. But a container is linked directly to an image we use to create a container. Then we have the Dockerfile. The Dockerfile is the file you use when you code what it should be included in a Docker image. We will see an example of a Dockerfile in a second. The Dockerfile you define, we need to copy this binary, we need to put it here inside the image, we need to copy this other file, put it there, and then using Docker build command, we create the image. Then we have the Docker registry. Docker registry is the most common one, is Docker Hub. It's a place where we'll push all our images. So once we have the application ready, we push it to a registry, and then it can be pulled from multiple places anywhere on the internet. Of course, we can have a private registry. Docker Hub has a private mode that you can only people from your company or your customers would be able to pull those images. Or you can create your own registry as well. There is a Docker image that you can use to create your personal Docker registry and push things to your own registry. Excuse me. Or you can use any flavor of Amazon, Google, Azure. All of them have their own solution for hosting Docker images. And then we have another term that we will see a quick example as well, which is Docker Compose. Docker Compose is my favorite thing ever. Even if I have to deploy only one image, I do like to use Docker Compose. This is a tool to orchestrate. This is a trendy word, orchestrate. We can orchestrate multiple containers and connect them together, all in code. So you code using YAML, you define how those Dockers or images are going to communicate between each other, if they're going to share any data or whatever. You define all that there in the Docker Compose file, and then you can get that Docker Compose, go to a different computer, execute, and having exactly the same application running. You can deploy databases, you can deploy like cache, like Redis, you can do multiple things. Okay, so let's see an example. We have a Docker file. As I said, we're going to see an example in a second. It's a text file with build instructions, the stuff we want to put inside the Docker image. Then we create the Docker image. We can see a few commands down there. With Docker build is the way we build our image, and we're naming it my app. And then you can use 2 dots to also version your images. If it's the latest version, you just tag it as latest, but you can say 5.6.7. So you can keep track of the different versioning of your images. And with the other Docker command we see down there, Docker run, And in this case, we're forwarding or we're mapping a port. We use P8080, 2.8080. One cool thing about Docker is that once we create a Docker file, we say this application is going to run in port 8080. Because that, for example, we can use WebBroker, and we configure that WebBroker is going to work in 8080. Cool. And we create the Docker image, 8080. Then I use that Docker image, but in my infrastructure, when I'm going to use that application, maybe the port 8080 is already used. And I want to deploy that application at a different port because it's in use. So I can do here, I can change this one on the left, the 8080, and say in my computer specifically, it's going to be 8081. That's it. The application internally will still work in 8080 because it's how it was built. But I'm remapping that port specifically for my infrastructure. And then at the end, I'm just saying the Docker image that I want to deploy. So here we build the application with my app, and then we're using it there. In case we wanted a specific version, we could use as well $2 and version blah, blah, blah. With this, what we've done, we've built the application in our computer. We have the Docker image in our computer. We have the Docker container running in our computer, but we need to push it somewhere so more people can use it. That's where we need the registry. And as I said, the registry, there are multiple options. And what we do, we can see that arrow on top. We push it from that machine, we push it to the registry, and then we can pull it from, in this case, it's a machine, but could be any other machine. The command for Docker run is going to be the same one in every single machine we want to run that application. Kind of clear? Yep. Okay. One question I usually get when I speak about Docker is saying, but what happens with the storage? Because a Docker image and Docker container, they're ephemeral. Once you remove them, all the content disappears. How do I store things? How do I create things and keep them safe for the next time I launch a new release, a new version, and that container is going to be overwritten with a new version? That's why Docker storage comes in place, because as I said, Docker containers are ephemeral. But we have two concepts. One of the most popular ones are Docker volumes. You can think about Docker volumes as like tiny hard drives, virtual hard drives that you create with Docker, and you assign a name, Docker volume my app. And then we can link that volume to the Docker container. So all the data will be stored in the volume once we redeploy the same container. I don't know what's going on with my throat. Once we redeploy the container, all our data will be persistent. Another way, if you don't have a very big deployment, and maybe you have this one server, it's not recommended because you're coupling your deployment with your specific computer. But I personally use it a lot for testing or for my home lab because I only have one server, which is bind mounts. You can map a specific folder of your computer or your server to the path where you define in the Docker image that things will be stored. So you can go from the terminal, you can go to that folder, and you will see all the data, a SQL-like database, logs, whatever. So instead of Docker volume, there is a bit of this exotic thing that we don't now have to access, even though you can. But sometimes, mostly if you're learning, it's easier to just map a folder from a computer, the equivalent in Docker. Okay, what are the benefits of using Delphi for creating Docker? Because a lot of people are saying that we need to use modern languages to create microservices, and we need to use Node.js and .NET and Java, because those are the standards now for creating microservices. Well, Delphi has one of the biggest advantages out there, which is we create native binaries with zero dependencies, unless you introduce any dependency like a library to access a database or stuff like that. But the binary itself you create with Delphi has 0 dependencies. It doesn't need any runtime. You just use a base image. You can use Ubuntu, you can use Debian, you can use, we don't support Alpine at the moment. We're working on that. But we support distroless. I will show you an example later. Anyway, it has a very small footprint because it has, as I said, minimal dependencies needed to the container. The demo we're going to see has 0 dependencies. Performance, we don't need a runtime. We have a native performance running inside a container. It's instant execution. We don't need to run Java or .NET or whatever. So just, and cross-platform, of course. You can still have some of your business logic of your application even shared with a Windows application if you want to. For example, you can have all your database access layer being used for your application and then share the same units for Windows if you wanted to. A bit complex, but it's absolutely doable if you wanted to. Imagine you're following an MVC pattern and you have your models on one side. You can reuse those models in multiple applications, not only for microservices but also for Windows or even mobile if you want. Okay, so just as a direct comparison, we can see Java there. Yeah, we're talking about numbers, yes, of the space you need to just start thinking about using Docker. With Java, because we need a JVM, the container we're going to start in 100 megs. Then add all the dependencies and everything on top of that. So we're starting in 100 megs. .NET, 80 megabytes.
Do you need some water?
Sorry?
Do you need some water?
I think I do. Thank you very much. If you don't mind. On Delphi, we can see that the binary is going to be between, of course, it can vary a lot based on what you put in the binary. But we can talk about between 5 and 20 megabytes. Thank you very much. Okay, so let's compare. I've done a bit of a research and compare the average size of different languages. So if it requires runtime or not, and the average container size, of course, this could vary a lot based on what type of project you're developing. We see Node.js, the average container size for microservices is between 100 and 100 megabytes. If we use Python, between 100 and 200. .NET, between 200 and 250. Java, between 200 and 300. And of course, we have the 2 winners. We have Go and we have Rust. You can make very, very small containers. But we need to remember that Go was created specifically for microservices. That was the core fundamental of why Go was created. It was because this was a problem. That they called them microservices, but they weren't micro at all. Because you can imagine that if you have like 50 or 100 microservices, and if you're using .NET, you're going to need to put in every single microservice the .NET engine inside. That's why Go was created, so you can compile binaries, native binaries, and put them inside Docker images. With Delphi, we can see that we're not as good as Go and Rust, but the numbers are not bad at all. We're talking about between 30 and 50 megabytes. And we need to remember that with Delphi, you can do way more things. Do you want to develop a mobile application? You can still do it with Delphi. You can want to create a desktop application. You can do with Delphi. Do you want to create Docker images? You can do it and end up with a very, very reasonable size and very optimal Docker image size. Okay, so let's see a sample, a very basic sample of a Dockerfile. I was talking about Dockerfiles earlier, and this is it. So this is the most basic Dockerfile you can create. And actually, this is almost the one we're going to see in the demo I've created. We always start from let's say a pre-made template of the type of libraries we want to have access to. The most popular ones are Ubuntu, you have Debian, you have Alpine. There's a whole myriad of different pre-built Docker templates or Docker image templates that you can extend from. What this does is saving you time of copying all the, I don't know if you want to have V inside or you want to have SSH access. All that stuff comes already pre-configured in the base image you're going to use. There's a whole myriad of that. For example, there are plenty of Docker image file templates. For example, if you want to use .NET, you have one already pre-built with the specific .NET version you're going to use. That base image is going to be already 100-something megs, but it comes with everything pre-configured for you, so you only need to copy the files you require from .NET. With Delphi, we can use it at very basic because we don't have any dependencies or anything. So we can use a very bare bones foundation for our application. Then we create an app directory. This is where all our binary will live. We say, okay, let's copy our binary. That would be the Linux compiled binary. And we copy it to app. And then we expose the port where this application runs. So we're telling this Docker image will expose the port 8080. And what it needs to do once we run this Docker image and we deploy it as a container, just run the application. That's all we need to do. Yeah? Now I want to quickly talk about something that not a lot of people are using, and it gets along very well with Delphi, like very well. And that's WSL. That's Windows subsystem for Linux. In case you don't know, you can activate Linux inside Windows 10 or Windows 11. What that lets you do, you can install Docker inside that Windows subsystem for Linux, and then you can use in PowerShell some commands to execute all this stuff. And you can integrate all that within Delphi, because you can use post-build events. And you can say, once you build this, we're going to see the example I created is based on that idea. Execute this PowerShell. And what it will do for me, it will create a Docker image. And if I want, I can push it to Docker Hub or to any registry. I can even deploy locally if I want to test it as well. And all that integrated within the IDE. As I said, there is one caveat. The only caveat we have with Delphi is that to build for Linux, you need to have PA Server running. PA Server, it's the application that connects between, we use the same one for iOS, for macOS. It's an application you only need to run, and that's it. And then it connects to the Linux subsystem and grabs all the binaries that need from the Linux subsystem to be able to create the static binary. But let's see a demo, and I think that all this hopefully will make more sense. I'm going to come, I think it's this one. Let me quickly check. I had a bit of a trouble. Okay, it's this one. Because ironically enough, with this laptop, I couldn't do my demo. Because it's a Mac. And Mac is an M1, and M1 doesn't allow nested virtualization. It's only possible to do it from M3 plus. So because I'm running Mac, as you can see here, this is a Mac, then I have virtualized Windows inside the Mac, and then the Windows subsystem for Linux, it's another virtualization layer inside the virtual machine, and Apple doesn't let M1 and M2 to have nested virtualization. Just FYI. I spent a whole morning trying to debug that, so I just say So what I'm going to do, not a problem, I'm just connecting through RDP to my computer in the UK, and I'm going to demo it directly from my computer. So this, just FYI as well, this repo, I published it on my personal GitHub account, so if you scan that QR code, you'll be able to download this very demo I'm going to show you here. Okay, so this application, what it does, first let's run it on Windows, shall we? So we can see what it does. Let's put it in release mode. Let's execute it. And this is a very basic web broker application. Just as a start, I actually coded it in a way that it starts automatically, so I don't need to type start. And it exposes the port 8080. So if I come now to the browser, I can localhost 8080. Welcome to the Delphi Summit. I use very basic HTML with web stencils, which I will be talking about tomorrow. And we have this, and I created like a mock health endpoint that is very popular in microservices as well. So if I access here, it returns me absolutely fake data about the status of the application. But it's just so you can get the idea. Then we can create a microservice and publish as well a JSON where we can ask the stuff about what's going on with the microservice. So this is what it does. Code-wise, this is, if we come to the source, view source, this is almost the default web broker project. So if you go, in case you're not familiar, web broker is a way to create web services with Delphi. You can come here to File, New, Other, and we have here under Web. You can create a web server application that is compatible with Linux, with Windows, and you can create APIs, you can create a website or whatever you want. It has been a bit forgotten because not a lot of people were using it, but now since we're bringing web stencils, it is having again like a big comeback. And well, it's recorded on mine in version 13. We're gonna make it much better, Delphi 13. But yeah, I had to tweak a few things just because I'm very, very anal about things, and I was having a problem when I send the kill signal to the Docker image. And it takes 10 seconds. And I want the stop to be instant. It's just because it gets in the loop in the Docker container. But anyway, you can check so I had to add some extra code to make it compatible. I created also a compile directive to know if I'm on container mode, or if I'm on Linux mode, or if I'm in Windows mode. You can check the code. We're not going to go through all the code, but it's just 200-ish lines. This is for running the service itself. And then we have only 2 units. Well, one is just literally the constants we can see in the console, which is not really a unit. And then we have the web module, which is empty. It only has 2 actions that we can see here. And we have the root, which is the welcome to the Delphi thingy you saw, or that is the root of the website. And then we have the /health. And if we come to the event, here on the health, I'm just saying that the response is going to be a JSON. And as I told you, I'm just mocking some data. And I also say in which, if I'm running in Linux mode, I'm running in Windows mode, or if I'm running in container mode as well, using the compile directives. And the other one, the other endpoint, is just a stuffed here thank you to the triple quote string literals. Now I can put big chunks of HTML. And I directly put it there in the response. So actually I didn't even use web stencil. Now that I just realized that this return has stuffed the whole HTML there. One of the best things ever, I have to say, the multi-line string literals if you're not using them. For SQL, for JSON, for HTML, for a bunch of stuff. So yeah, this is the application. So this is our very, very sad web service because it doesn't do much, but it's just to prove the idea, yeah. So this is something that not a lot of people do, and you can create more modes apart from debug and release. those are the ones we provide you by default, but you can customize this and create your own. So what I did is, under release, I created one called Docker, because I want to do different things once I build for Docker than if I build for Windows or if I build for Linux. So let's move now to Linux, and let's activate Docker. What I did here, if we come to edit, I come here to build events, and I define that if I'm building for Docker, I want to execute this command post build event. That means if the build is successful, I want to execute this PowerShell. And it's literally one line. Of course, the PowerShell has more stuff, but we're going to see it in a second. So let's come now to the PowerShell that I have it here. And this PowerShell, it's again available in the GitHub repository, so for you to check. And most of the lines are primarily checking if things are where they're supposed to be. If the binary is in the Linux Docker folder, so if the binary exists, if I can create this, if I cannot create that, so I get an error in case that something goes wrong. But the command to do the Docker build, it's literally this line. Docker build, I personally don't like to cache things, so I prefer to do the whole build. And then the image name that I define as a variable, the image tag, and then the path. And that's it. So every time I build and release Docker mode, it's going to create for me the image automatically. So let's give this a shot. What we're going to do, I'm going to close this one in a second. I'm going to open Ubuntu in case you haven't seen WSL. You're going to see it in a second. This one. I'm going to have a serious, there you go. So now I'm on Windows, but I'm Linux. So something I do like, you can come to Mount and you have your C here. So if you do like your C and get your documents and stuff, you have access directly from Linux as well. So I have PA server, let me maximize this here. And the only thing I need to do, I need to access PA server and run it. And I can leave that going. Actually, because I found this a bit annoying, I'm going to lie, I created a Docker image myself for PA server that you can have it running somewhere, and then you only use it to connect and build your Docker image. It's available in the Embarcadero Docker Hub. So okay, that's running there. Now I can come to Linux here, and it's pre-configured already, so the connection should work. Yeah, I'm connected to PA server. So, and just to prove that we don't have anything here, I'm going to open another Ubuntu. If I do Docker images, I can see all the images that are created in this machine, and we have none at the moment. Okay, so if I come here, Docker, and I say build. And it's doing the building, it's doing the compiling, and at the end, it's going to execute the PowerShell. Done. Okay, so let's come back now to Ubuntu. Let's execute the same command. And we already have a Docker image built there. And it's 28.9 megabytes. If we upload that to a registry where things are compressed to use less space, that's going to be roughly like 10 megs, I think. So you can imagine how quickly you can deploy applications built with Delphi. Okay, but now of course we want to run this. We have the, how do we run things? We saw in the slide earlier that we can use Docker run. And if we want to be very lazy, we can say, okay, the port, if we remember in the Docker image, Dockerfile, sorry, we were exposing port 8080. So that's our reference, the port we're going to have available in this application. That's not here. So port, and I say, okay, but then my application, I don't want 8080 because, you know, I'm weird. So I'm going to use 8080. But the application runs in 8080, so I need to respect that. And also, I personally like to assign a name to my Delphi, to my Docker containers, because otherwise random name is assigned, the random word. So I like to let's put here Delphi Docker, and then we're going to use the name of the Docker image I just built. Delphi Docker, I miss a C. Delphi Docker. Okay. But now I can see that the application is running, and I have this console thing going on. But I wanted to just deploy it and don't tell me anything. I just want it to run. So what we can do, there's an extra parameter. Let me finish this, and I can add here. This is Docker standard. This is not Delphi related at all, even though I like the letter. I add D. That means detached. So when I'm telling this Docker, saying run, and don't ask me anything. I think I'm gonna get an error because the image is gonna exist with the container is gonna exist with the same name. There you go. So what I need to do, I need to stop the previous one I created with the name Delphi Docker, and then I need to remove it. And the command is docker rm, which is rm, standard in Linux to remove. And I can remove it now with the name. Okay, and now if I run the same command in detached mode, there you go. The application now is running, import 8088. Let's come back. Now here, localhost. The previous example, we ran on Windows, it was 8080, and now it's going to be 8088. And so this is
localhost on Windows is also
the Linux subsystem. Okay, it redirects everything automatically. Don't ask me why, but I love it. So it's localhost, and it does the whole port mapping. It's really magical.
So what if you have a service also running on the Windows system that listens on the same port?
You cannot deploy. You need to find a port that is available on your VM. Your VM, your computer, your infrastructure.
But it will say this port is already used.
Yes.
Okay.
And we have exactly the same functionality. We can access help, and now it's telling us that we're running in container mode because it was that compiler active. So I know that this is running in Docker. But now the beauty is I can push this to a registry, send the name of the image to any person, and the only thing they need to do is execute the command docker pull and the name of the user / the name of the Docker image, and they will have this already in their computer, just waiting to do Docker run and execute it. And in their infrastructure, it could be 8080, it could be 8123, it could be whatever you want. Okay. Of course, this is a very basic example. I just wanted to introduce you to also this little trick that you can use a build event to simplify all this. In this case, this PowerShell, it only builds the image, but you can do way more if you want to. In that PowerShell, you can add, if the build is successful, then push it automatically to the registry we have somewhere and tag it. Get the version of the dprog file, extract the version, and put it at the end to tag it correctly, and then the version will be the same one as we have in Delphi. You can do pretty much whatever. And that, my friends, we're getting into the CI/CD territory here because we're starting to automate things. Of course, pure CI/CD, you should use like Jenkins or GitHub Actions or stuff like that. But there is this very cool little thing called GitHub Runners that what you can do, you can install it in your computer, the GitHub Runner, and then it will have access to your computer. So you can configure your GitHub repository and say, every time there's a commit with a tag, for example, connect to this runner and execute this. And then you can configure automatically that every time you send a comment or a pull request or whatever, that you get deploys done automatically. And that not only for Docker, you can do it for anything. I remember I worked in a project that every time we created a new version, we uploaded to an FTP, the binary, it was a VCL application, and we pushed it to an FTP with a version at the end so customers could download it automatically. And all that was done using GitHub Actions. And it's mostly with AI. With AI, it's brilliant, because now you can ask all this very complex stuff you have a very clear idea of what you want to do. The problem is you don't know the syntax. So you can just ask AI, I want to create a workflow for GitHub Actions that does this, that, that. I have a GitHub runner, running an application, how can I do this? And then from there, you build your own GitHub runner to do all the stuff you want to do. And this just died, sorry. Okay, we still have a few minutes. We have a couple of extra slides, but I want to also show you something I have hosted in my own little server. We will talk about this tomorrow if you come to my Web Stencils presentation. My last name, Zapater.dev. And we have the demo I created a while back for Web Stencils, which is a library to create websites, but I made it in Docker. And I have it available in my Docker Hub account. Just so you come tomorrow, I will give you the details tomorrow. I'm not going to do it now. But yeah, you can pull this demo, and this one is way more complex because it has database, it has login, so we need to map the volume, so we need to do a lot of other stuff. That is something actually I should demo as well because this little demo I just showed, this one we just discussed, it comes with a very bare bones, I'm not very proud of it, logger. So because in Docker something you do need to do is to create a good login system. There are very good login libraries already out there, compatible with Delphi, that are literally, you add it to your library and off you go. You have multiple ways to log in. The problem with Docker is things just, as you just saw, I detach the container and then what's going on there? What's happening? I need some feedback, I need some data. So you need to create a lot of logging. For this demo, I created like a very basic info, error, debug, blah, blah, blah. But I didn't even use half of those. So what I can do, actually, let's do it, just as a proof of concept. I want to stop this Docker container I just created, so it's going to be Docker stop, the name I assigned to it, Docker demo. Then a raw error is gone from
We named it Delphi Docker.
Oh, yeah. I typed it. Thank you. I'm going to remove it. The thing, that's something that also people struggle is just you cannot modify easily a Docker container that has been deployed already. Saying, but I want to map now this volume to this Docker. No, you deployed it. You need to regenerate it. That's why we tend to write all the commands and make things automatic as much as possible. So, and there are solutions like what's the name? Portainer, which is a very popular UI, web UI to manage Docker, and it gives you the impression that you managed to do that, which is I want to hook this volume to this container, and you click OK, and magically it happened. But what it did behind the scenes is removing the container completely and running again the Docker run with the proper command. That's a whole other session if we want to talk about that. Okay, so if we come here to the same Docker run command and we come to the Dockerfile, we can see here here we have an extra one that says create a volume for. So this is the way we define in the Dockerfile which paths we're going to allow external access to, because we cannot connect to any folder we want in a Docker container. We can only link to folders that have been specifically defined to be accessible from the outside. So in this case, we have app logs. It's not mandatory, as you just saw the example. Now the logs were being created inside the Docker container itself, but I cannot access them. But what I can do, I can come here and say, I'm going to V for volume, and I'm going to map this to a local folder mnt, I don't know, data / Delphi demo. And this one is going to be, Same thing with the port. As we saw earlier, on the left we see the port we want to map, and on the right is the port that the application runs itself. And in this case, I need to say inside the container, the logs are in app. Logs or log? I don't remember. Logs. Oh, I didn't remove the. There you go. Now, if we come to see data, we have a new folder that has been created, Delphi demo, and then we have app.log. And if we open this text file, this is some bit of random login I created just for the demo. And this file was already before and the previous deployment, but it was stored inside the container. But in this case, I linked it to bound it to a local folder, and now the data is persistent because it's going to stay. Even if I regenerate the container, the data will stay in my folder or Docker volume if you use a Docker volume. Okay, I just have a handful of other slides. I only wanted to mention these two technologies. We're not getting into them. But just because they're very popular, probably you've heard about the bloody Kubernetes thing constantly everywhere, that apparently if you're not using Kubernetes, you're not doing it right. And I just want to say that it's Docker on steroids, really. But the technology and the Kubernetes is all containers. They're not using Docker anymore, but that's a different story. But it's the only thing that does Kubernetes that is very interesting for big companies is that automates deployment even more. The scaling is ridiculously easy once you have configured it correctly. And the thing is, it load balances automatically. For example, you can define a number of replicas that you want for high availability. So you can have replicas of the same image container, replicas of the same image. In case one goes down, automatically jumps to the others. You have also this elastic scalability. That what it means is you just deploy more. And also the self-healing. So they use all this marketing words. That what it means is really just a very clever way of using Docker. But it's a pain to learn Kubernetes if you want to learn it right. You have an alternative that I personally played around with, which is Docker Swarm. It's like a toned down version of Kubernetes. If you have your own infrastructure, you just want to play around with it, it's as easy as installing Docker and connect those two nodes, and then you will have a Swarm. And then you can deploy, you can play around with HA, stuff like that. We're not going to go into details, I just wanted to mention that these two technologies are also very, very popular. But personally, I do like Docker Compose, and I use it a lot for a lot of reasons. We're going to see a very simple example of why Docker Compose makes a lot of sense for not massive deployments. Also, I like to say, because with microservices, you can see a lot of companies say, yeah, we have 120 microservices, we have 200 microservices. And I usually ask them, if you have more microservices than customers, you're doing it wrong. Because you don't need that many microservices. Because afterwards, it's an absolute pain to maintain that. And things happen and you don't have control, and then you need to add a lot of login. Then there's one you need to add, oh God, what's the name of that thing? Prometheus, and then you need Grafana, and then you need, it's a whole bloody thing. So you need to scale. Not because it's trendy, but because it makes sense. So, coming back, Docker Compose. In this case, we can see that also we follow a very basic approach. In this case, it's a YAML file. In case you're not familiar with YAML, it's pretty much like JSON, but without the curly braces. And we define indentation just using indentation. Personally, I'm a big fan of YAML because it's much easier to read than JSON. But this is, well, it doesn't work on the TV, interesting. Okay. So in this case, we have two services we're going to deploy. We have the Delphi app API, that could be any API. We have the image we're going to use, which are the images we just built. And then we expose the port. In this case, we're going to map 8080 to 8080. We can define environment variables that will be available inside a Docker container, and we can grab those from Delphi as well, because they're variables of the environment. And then we can start doing things that are quite cool. We can say this container cannot be executed until database is running. And what is database? It's another service we have inside the same Docker Compose. That in this case is a PostgreSQL version 16 specifically. And also we define environments with the database we're going to use, the user, the password, and then the volume, because this is the Docker container that we want to have persistent data, the database. This application, we don't need the data there, potentially, unless we want to log in or other stuff. So in this case, and then we create a volume named DB data, which is the one we're using to store the PostgreSQL database. In this case, we can run this and it will be run as a stack, which means that both containers are coupled together. And in one command, we're going to deploy the application and the database, all running in Docker. And they will be stored, the data will be stored in that volume. This is a very, very powerful way of having, let's see if I can say this, replicable applications, because you send that Docker Compose to any of your customers, and the only thing they need to do is run it, because it will deploy everything automatically for them. And something that some customers don't find it, not customers, people, they say, okay, how can I connect to the PostgreSQL? I want to use, I don't know, Haiti SQL, or I want to, so in this case, you can't. The whole idea of this is making the database as secure as possible, and the only way to access the database is through 8080. If you want to access the data, you will have to go to the terminal, and then you will have to access to the volume and analyze the data. Because exposing the port of a database in some environments is considered bad practice. And in this case, that's completely fixed, because the communication is between the two containers. And that container is the only one that will have access to the database. If you want to expose the port to connect using Hy-V or whatever, or the Beaver or whatever you use, you can put the port there and say, I'm going to publish the port of the database. And then you will be able to connect to the port. So this gives a ton of flexibility, and it's not Kubernetes or Docker Swarm or stuff like that. In this case, we see only two Docker containers, our application and the database. But you can add 4, 5, 6, 7, 10 different Docker images. And in just one Docker Compose up, that's the command, Docker Compose up, it will create all the containers automatically. And if you stuff that as well in your repository, in your repository, GitHub repository or whatever you use, everyone can create this exactly the same environment for testing or for your customers or whatever. So you can see here the command, Docker Compose up detached, and it will create everything for you. And that's it. We have 4 minutes for questions in case you have any. Yes.
You started with Linux development by starting the PA server. In my opinion, you only have to start it on a PA server when you want to debug in the Linux environment,
Yes.
or if you want to pull new data from the Linux compiler.
Yeah, exactly. I like to say people have a PA server running, because I've seen some people, for example, if you update your Linux machine where you use PA server, maybe some of the binaries of that have been updated.
You have to do it manually.
Yes.
You still have to go manually to create new SDK.
Once you have all of the data you required, so Delphi is capable of building, you theoretically don't need PA server running every single time. That's very true. But I tend to recommend people to have, that's why I created a Docker image for that. So I have it running somewhere and I can connect to anywhere. But yeah, it's the first time you want to build for Linux, you need mandatorily PS server, so you can pull all the data required for the Linux machine. And yeah, if you want to debug, then mandatory, you need PS server. Any other questions? Does that mean that I explained everything very well?
Is there you used the web broker example? Is there also a service that can use WebSockets in Linux?
Yes, we don't provide that out of the box with Delphi. We don't have a library that I saw Marco here earlier. You can ask him because we don't have a component for WebSockets. That being said, there are components out there that support WebSockets
On Linux as well.
Linux as well. ECGC is one of the companies that create WebSockets, and I've used those specific components on Linux.
I think it's not working.
Oh, I didn't publish it. Oh. Okay. Because I uploaded last week and I didn't want to. Okay, give me a second. We're gonna do it live. Oh. I'm falling in my own trap of security. Authenticator, this one. Okay. So this one is going to be Delphi Docker demo, and yeah, of course I left it private. So let's make it public, shall we? I think that was. How the hell do I make
change visibility at the end?
there? Here.
After 36 clicks.
Could you try again?
But
It's there.
it's more like a discussion and question. If you made it look simple, but from other people I know that I don't know anything about Docker, but I know that it could be a bit of a madness. So at one point, if you only have a non-visual application, only a non-visual application, isn't it easier in the end to convert your application to?
Yes and no. Depends on how the code looks in your application. If your application is like 25 years old and it's a bit of a spaghetti situation where everything's highly coupled with all the data sources and there's a lot of stuff in on-click events and it doesn't follow a kind of a pattern to have things abstracted, etc., it's going to be a lot of refactoring. I'm not going to lie.
Because if you go with a Docker, you'll keep the madness forever. But if at one point you convert your application, you'll do it properly.
It's doable. I was talking earlier that I had a chat with a customer and they wanted to migrate from Delphi to .NET because they wanted to use microservices. And I said, that doesn't make any sense to me. So I explained them this kind of things and of course it implied for them because they were ready to do a whole rewrite of their application in a different language. But once I told them that they could do that rewrite reusing a lot of the code they have already, that looks way more achievable than not starting from scratch.
If it's a non-visual application, mostly you'll deal with paths, problems and stuff like that with folders, but it's not that difficult to convert it for a non-visual application.
Yeah. I cannot give you like a silver bullet saying do this, this and that because each project is different.
Yeah.
But it's definitely achievable.
Yeah, I just wanted to mention that if you don't do it at one point, you'll go forever with an old application.
Well, I'm afraid we've run out of time, but is it okay if we spend 1 minute more? Yeah.
If I update the host class, do I have to rebuild all my containers or my images
No.
with no internet?
You will have to stop them if you want to. If you update the kernel of Linux and you need to reboot your machine, you will have to stop the containers, of course. But you can, once a container is created, you can stop it and then use Docker start and it will run again. And even if you update the kernel of Linux, you don't need to recreate your containers or stuff like that. That's one of the beauties of well, with like tiny VMs.
Maybe one Docker related. So you am I right that you use or installed Docker only in the WSL? So you didn't use Docker desktop there?
No.
Yeah.
One of the reasons why I didn't use Docker Desktop is because otherwise, because I'm in Embarcadero, I will have to pay a license. Because they don't let us use, I mean, of course I will pay a license, but I remember when I said I wanted to do this presentation, Embarcadero said, okay, buy a license. I said, I don't want to, I don't need a license. I just need Docker for the CLI. I don't need Docker Desktop. There's that option as well. You can download Docker Desktop. It's free for small companies or for, I don't know the terms really. I only know that in Embarcadero we passed the threshold. But what it does is just, it makes your life a bit easier, but it uses exactly what we saw today, which is it uses WSL. And then you can see visually which containers you have running, and then which images you downloaded. But for that, I would personally use Portainer, which is a free alternative that is UI. But that's, yeah, this was just a intro kind of situation, but we could.
So I got stuck on that one line in your PowerShell script where it says WSL Docker, and I wondered why it says WSL at the front, WSL at the front.
Yeah, because that's what to execute from PowerShell.
Yeah.
To execute stuff that is going to be run in WSL,
Yes.
you need to specify that on PowerShell.
You would not need that if you had Docker desktop. Okay.
Yeah, well, thank you very much.